terminal on that isolator. What the isolator does, it allows current to flow that way and this way to these two terminals, but does not allow those two to see each other. Okay? So what they would do is one would go to this side of the boost solenoid, one would go to this side. Well, that means while you're driving this spooled up and putting power to here, current will go to here, charge this battery. Current will go to here, charge this battery. Isolator allows the alternator to charge both systems, but systems stay separate. Okay? That's what that's all about. And this is, excuse me, this is pretty well what you have inside your coach. On this terminal, on this two gauge going back here, back behind the cabinet on the driver's side, there's a terminal on the wall. Cable comes to here, this cable goes to the back, this one comes over to the living area fuse box. All the fuses in it. And then tied to this terminal right here is your power converter. The converter takes 110, creates 12 volts. It's a charger. So when you're plugged in and the generator's running, power converter gets power. It puts power to here, charges this battery. It also puts power back to here, to this point, but because of the isolator, it cannot get to this battery. Okay? Which is okay, because theoretically when you're driving, this is charging it. And when you're sitting, you're using this. You plugged in, it's charging that. There's a couple of things that we like to put in. First of all, I like to move this battery. Okay? I like to move it. The reason is, I'd like to have all the batteries up front. Because, well, some people say, well, more weight up front, more traction, that's kind of silly. It's only a battery. But having both batteries up front, the living area and the engine battery up front, gives you the opportunity to put an on-off switch right here, and then goes to here. And then you can put another on-off switch right here, which goes to here. Now you have an opportunity to shut both batteries off in one place. You can also service the batteries in one place. You're not going to the back, you're not going to the front. A lot of fires in RVs are electrical fires. Okay, electrically ignited fires, Class C. If you can turn off the power, you change a Class C fire to a Class A or B. Class A is burning wood or you or whatever. Class B is vapor fires. But if they're starting with the ignition source, which might be 12 volts, you have a fire. If you can run out and lift that hood and shut both of these switches off, you've killed all the power to the coach. And maybe it won't melt. Okay? So this is the reason we put these two switches here. Okay? Now, another thing, remember we said that okay, we have the generator back here. When we put the battery here, power now flows from this battery to this point, down to here, to the fuse box, right? Living area fuse box, and then it carries on to the generator. That way, this generator can start from this battery up front, and a 2-gauge wire running that far will do it. An 8-gauge, like they did in 73, wouldn't do it. 2-gauge will do it. Batteries are up front in one location. You can turn them off, you can service them, real nice. But remember, when this is energized, this power converter, it's only charging this battery. Power is getting to here. Charge is getting to there, but it's not charging this battery. Well, what we like to do is we put a third switch. And that third switch takes the living area electrical system, an engine electrical system, and can tie those two together. Why would you want to do that? Say your alternator stops. red light comes on the dash. If you're in your car, what do? Roll the windows down, turn off the air conditioner radio, and look for a shop, because you know you're running on your battery, right? Well, you have an option. This is a countermeasure. This is a backup. If you lose your alternator, what you can do, fire up your generator, right? The generator creates 110. That runs the converter, charger, right? That charger will charge this battery, comes over here to this point. You flip this switch on, puts power to this side, which goes to the battery. Okay? If you have this option with this switch right here, now you could push the boost solenoid and stick a toothpick in it. That would do it, because that's what this boost solenoid does electrically. But this is not a continuous duty device. Continuous duty device means that it will dissipate the heat it creates from operating. This will pull about 4 amps, and eventually it'll burn up. So we don't want to do it that way. You go up front and turn this on, no current drain, positive lock, 2-gauge, heavy-duty marine switch. You'll be able to fire the generator, run the power converter, put power to here, which puts power to your engine battery, and you can drive to California or Florida, which side you're on, without the alternator, because you're charging here. Okay? That's what we call this a combined switch. Combined switch. All 3 of these switches are marine style. There's several: Blue Sea, Perco, red switch. They're made for high current. They're made for a boat, to kick the boat battery off when you're not using it. See, that's a great idea. Not only is it a great idea for boats, it's a great idea for motorhomes. If you're going to park the coach for 3 or 4 weeks, turn off the batteries. You don't need them on. We talked before, if you do leave it on, you have 300 milliamps, 300 to 500 milliamps worth of current drain on your radio to keep your radio stations. Your refrigerator pulls about 500 milliamps on the control board that runs that. So if you let that sit for a long time, when I say a long time, a couple of weeks, 3 weeks, and you're not there, not doing anything with it, that's enough that it may drain down a battery. Even if you put a second battery, we'll talk about that. Even if you have a fresh, brand new battery. I mean, if you go to the airport and you park your car in the long-term parking for a month, might not start. Same situation. So these switches are here to help you not have that happen. If you're going to be away from the coach, I'm not talking about going to lunch and coming back out. Come on, guys. I'm talking about you're going to be away from it for 3 or 4 weeks. You're not going to be there. Nobody's going to be there. There's no reason to put power in there for the ants or squirrels or something. So just turn both batteries off. You'll know when you come back to it. Is it going to start? Well, if you turn the switches on, chances are the batteries are going to be okay, because they've been sitting there static. Very, very important. When I start GMC, I push the boost switch in before you start it. Why? Well, when you hit the boost switch, this ties all of it together temporarily, all your batteries, and that throws all your batteries to the starter. And that's a good thing. The highest current, 12-volt current device in the motorhome is the starter on the generator and the starter on the motor. Okay? So the more current you can give that starter, the better it runs, the less heat it creates, the less heat the cables create, the less corrosion you have, less everything. It's all good. So push the boost switch, fire it up. You may have to get kind of backwards. Start up your engine with the boost switch on. And it even wouldn't hurt to start up your generator with the boost switch too. When we do restorations, we put a generator start-stop switch up on the dash because the original coach, of course, the boost switch is on the dash, but the generator switch is at the door. So you'd have to have really, long arms to do it yourself. So these are some modifications on a general standard GM floor plan that we like to put in. We like to move the batteries up front. We like to have turn-off switches on the batteries. We like to have a combined switch on the battery, on the 2 batteries, so we can put power anywhere we want. Hey, look at it this way. Say your engine battery broke a plate. No good. turn it off. Your living area battery is working great. Turn this switch on. Now you can run your engine from your living area electrical system, or vice versa. It's important to have 12 volts when you're on the road, because when you don't, the party's over. You're not moving anywhere, you're not seeing anything, it's a real problem. And with 2 batteries, with 2 electrical systems, with an opportunity to charge here, you have a lot of options. And that's what you need when you're on the road. These things are too big to push. Your tow bill is going to melt your wallet. So you need, if your problem is no power, you got to work something out. And these switches, the way you look at this, will help you out. So I hope this answers the question somebody wanted about batteries. Oh, one other thing. 3 batteries. You say, some people say they have 3 batteries. Well, okay, let's draw another battery over here. Oh, there we go. Escher has no problem with me taking his job. Well, if you have 6-volt batteries, well, you tie them together from the negative side to the positive side to the negative side of this battery, and then coming out of here, that's 12 volts. We talked about that before. I'm not that hip on it unless you're going to be off the grid and you need a lot of current. To me, the better battery by far would be a 12-volt deep cycle marine battery. Why a marine battery? Well, that battery is designed for some guy to go out shrimping all night. Continuous low current drain. Then when he gets